paper using a scale of 2 centimeters to 1 unit on both axes. So 2 centimeters to 1 unit. So this box here, this graph here, from this point to this point, this point to this point is 2 centimeters. This point to this point is what? 2 centimeters. Are we together? So 2 centimeters to represents 1 unit is like 0, 1, 2, 3, 4. Okay. So using a scale of, look at this one. So some would say, oh, there was an inequality on transformation. No, that's not an inequality. It's a range of values from 0 to what? To 7 on the x-axis. Then on the y-axis is minus 4 to positive 4. Okay, so I can say 0. I put my 0 right here. Then 1, 2, 3, 4, 5, 6, and what? And 7 on the x-axis. Then the y-axis 1, 2, 3, 4. Then to this negative region, negative 1, negative 2, negative 3 to negative what? To negative 4. Okay, so that's what the scale. That's our scale. Okay, so I'm going to draw the lines. Okay, you'll be able to interpret correct the Cartesian plane and the scale. Okay, so that's my Cartesian plane. So this one is my x-axis and this one is my y-axis. Okay, so let's answer the question. Okay, a quadrilateral ABCD quadrilateral is a shape with 4 sides. Its vertices at what? 3 and 2. That's A. So 3 and 2, right? Then 4 and 3. So 4 is for x-axis, 3 is for y-axis. So 4 of x-axis, right, and 3 for y-axis. That's right here. So this one is A. So this one is what? This one is B. Then 4 and 3. There's 4 and 2. 4 and 2, which is B. Sorry, 4 and 2. That's B. So 4 and 2. 4 and 2. That's B. So this point right here was what? Was C. I skipped it. Okay. So 4 and 3. That's what? That's C. Then 3 and 4. That's D. 3 and what? And 4. Right here. 3 and 4 was what? D. Okay. So that's our A, B. Okay, A, B, C, D. Okay, in that order. Okay, that's A, then B. So I'm using a pen so that it will be visible on our video, but we should always use what? Pencils. Are we together? Should use pencils. Okay, so that's shape A, B, C, D. Right. Draw clearly a quadrilateral A, B, C, D. So we've drawn it clearly. Draw quadrilateral A1, B1, C1. The image of quadrilateral A, B, C, D under a translation with translation vector 3 and minus 5. Okay, so they are given its translation. So translation vector is equals to ending point. Okay, minus what? Minus starting point. Okay, so we are given the translation vector, guys. This is our translation vector, 3 and negative 5. So I'm going to write 3, then negative 5 here is equals to ending point. It's the quadrilateral A1, B1, C1. That's the ending point. So I'm going to write A1, B1, C1, D1, right? Minus starting point. Starting point is, right, let's read our question carefully. Quadrilateral A1, B1, C1 is image, which means is the second shape of quadrilateral ABC, which means ABC is our starting point. So on starting point, I'm going to take these coordinates of A, B, C, and D. So that's 3 and 2. I'm going to write 3, 2 here. Then B, it's 4, 2. Then C, it's 4, 3. and D is 3, 4. Are we together? Okay, that's it. So these are the coordinates of the starting point. Okay, so let's make A1, B1, C1 the subject of the formula. Let's bring all these coordinates to this side. So 3, negative 5. Okay, so it will be positive. That's A, B, C, and D. So that's 3, 2. That's 4, 2. That's 4, 3, 3, and 4. Okay, so we're going to add. Okay, so it's now 3 plus 3. We get what? We get 6. 3 plus 4. 3 plus 4. That's 3 plus 4. That's 7. Okay, then 3 plus 3. Or 3 plus 4 again, that's 7. Then 3 plus 3, that's 6. So minus 5 plus 2 is minus 3. Minus 5 plus 2 is minus 3. Minus 5 plus 3, that's minus 2. Then minus 5 plus 4, that's minus what? That's minus 1. So these are the coordinates of triangle A1, B1, C1, D1. Ending point minus starting point. So let's draw it clearly. 6 and minus 3. 6 and minus 3. Right here, that's A. That's A1. Then 7 and minus 3. 7 and minus 3. That's B1. Then 7 and minus 2. 7 and minus 2. That's C1. Okay. Then 6 and minus 1. 6 and minus 1. Right here. That's D1. That's D1. Okay. So that's our shape. A1, B1, C1, D1. Are we together? And if we join our corresponding points, you can see we have parallel lines, right? Which will be equal in what? In length. So that's it on this one. Let's go to the other parts, right? So draw a quadrilateral A2, B2, C2, D2 with what? Vertices at A2, that's 1.5, 1.5, that's 1.5, and 1. So 1.5, right, and 1. So that's here. That's A2. Then 2 and 1. 2 and 1. That's what? That's B2. Then 2 and 1,5. 2 of x-axis and 1,5 of y-axis. Almost right here. That's what? That's C2. Then the last one is 1,5 and 2. 1,5 and 2. Okay. Right here. That's a small one. So this one, I believe it's enlargement. Alright, because enlargement is to make things bigger or smaller. Okay, let's see. Let's find out. Okay, so that's one. Okay, so describe fully the single transformation that maps ABC onto A2, B2, C2. So the first thing is to join our corresponding points out together. Let's join our corresponding points. Should join these corresponding points, guys, and draw these lines. Okay, so I'm joining B and B2, and I'm joining C and what? C and C2. Are we together? That's C and what? C2. Then that's D and what? D2. I'm joining my corresponding points. You should always join corresponding points. Okay, so as you can see, all these corresponding points are meeting at one common place, which is 0, 0. So this one is enlargement. Are we together? Because enlargement is if you join corresponding points, they meet at one common point, and that common point is the center of enlargement. So we're going to describe it is C item 2. Then you can write C item 2. Remember, all the working should be on the same what? On the same graph of paper. Okay, so I'm going to write in enlargement. Okay, then center center of enlargement is 0, 0. Okay, you can say origin. Okay, then scale factor is image over pre-image, right? So this one is our image, this one is our pre-image. So ABC was mapped onto A2, B2, C2. So this one is our image. So let's count the number of boxes here. This side here is what? It's 1, right? 1 over, this side is 1, 2. So we're going to say 1 over 2. Scale factor is image over pre-image. Image from the center over pre-image from the center. So it's 1 over 2. That's our scale factor. Or you can write in a matrix form. As long matrix enlargement, it uses matrix if the center of enlargement is 0, 0 or origin. So we're going to put half here and half here, then 0, 0 from our identity matrix with 1, 1, 0, 0. So these ones here, they are affected by the scale factor. So you can put our scale factor on this one, 1 half, 1 half, then 0, 0. So that's the describe the single transformation that makes quadrilateral A, B, C, D onto A2, B2, C2, D2. You can even write this one, this matrix is enlargement, center 0, 0 or origin, scale factor half. Okay. The other part, it says draw the image, right? Draw the image of quadrilateral ABCD under a 90 degrees clockwise rotation about center 1, 1. Center 1, 1. That's here. Okay. Center 1, 1. Then and label it A3, B3, C3. So I'm going to take a divider and right. So the center of enlargement is what? Is 1 and 1. It's 1 and 1, and it's 90 degrees what? Center of rotation is 1, 1, then 90 degrees clockwise. Okay. So that's our center. So we're going to transform A, B, C, D onto A3, B3, D3, right? So we can take every point and point. Okay, so we are going to take point A to the center. Let me use a marker so that it will be visible, right? So I'm going to use this marker. Point A to the center. Okay, right, clearly, right? Okay, so it's 90 degrees clockwise. Clockwise is this movement, right? Movement of what? Of our clocks. Okay, sorry about that one. Okay, so it's now 90 degrees clockwise from our protractor. So from our protractor, this center is right here. This is our center. So this center is going to align with what? This line right here. That's our center on the protractor. Then this line is going to align with this broken line that I've drawn using my marker. Okay, so I'm going to align it here. So as you can see, so 90 degrees is right here, clockwise, somewhere right here. Then I'll take my ruler and align with what? With this point that I've marked. Then I can take this one, this divider from this point right here. Okay, so this point right here. Then I'll rotate. Okay, so automatically somewhere here. Okay, somewhere what? Somewhere here. Then I mark this point and label it A3. Then I'll take another point, which is what? Which is B to this center. This center. Okay. Okay. Then I'll take my protractor again. Then align it from the center to point what? To point B. Then 90 is somewhere here. Then I can take my what? My ruler to guide me so that I won't get lost. Okay, so then I'm going to take my protractor from the center right here. Okay, rotate. So it means this point is what? Right here. That's B what? That's B3. Okay, then let's take another one. C to the center. Let me use a different marker. Okay, I'm going to use the black one. Okay, the center. So I'm going to rotate it. I'll take my protractor and align it from the center, trying to this side. So 90 degrees is somewhere here. I'm going to mark. Then my ruler is going to guide me. Okay, so somewhere here along this line. Then I'm going to take my divider from point C to this one. Then rotate it. As you can see, this one, this point right here is what? C3. Then let's take D to the center. You take every point to the what? To the center. So okay. So 90 degrees somewhere right here. So I'm going to mark it right here. Okay. So let me take my divider and my ruler. So my ruler is going to guide me somewhere here. Then this point to this point. Then rotate it. So it's somewhere here. That's where our D is D3. So this one is C what? C3. This one is A3. So I'm going to draw it. Guys, always remember you should use your pencils. The only reason why I'm using these markers and pen is for it to be visible to you. Okay, so this one. Right, so that's our shape. Our quadrilateral A, B, C, D was mapped onto A3, B3, C3, D3 by a rotation of 90 degrees clockwise, center 1 1. So that's our shape. Okay, so are we together? Okay, so let's go to the last part of the equation. Write down the matrix represent a stretch parallel to x-axis with a stretch factor 3. Okay, stretch it also uses matrix, right, from our identity matrix 1 1 0 0. Okay, so this one is x, this one is y, this one is x, this one is y. Okay, so it says stretch parallel to x-axis. So parallel lines, they are like this all together, right? They are like this. So you say parallel to x-axis, which means it's what? Okay, in the x-axis, but on stretch. If the stretch factor is on x-axis, you are going to what? You are going to put your stretch factor on the y-axis. So you say parallel to x-axis, so that's 0 0 here. So we are not going to put 3 here, we're going to put 3 on the y-axis. So I'm going to put 3 on the y-axis like this. So this one simply say one-way stretch factor 3, x-axis invariant or parallel to x-axis, which means opposite to x-axis. So it's on what? On y-axis. So that's the matrix which was required for us to draw. So that's our matrix. So that's 1 3 0 0, one-way stretch. So one-way stretch, then stretch factor at 3 is x is invariant or parallel to x-axis. That's it. So that's it for